They will be presented. Oh, you guys hear me? Yeah, okay, you guys. Okay, my name is Jennifer, and we're giving a presentation about fireworks. For centuries, fireworks have been used for entertainment due to the variety of colors, noise, designs that they can create. And as they progress, the complexity and variety has also grew alongside with human scientific innovation. The creation of fireworks has become its own science with complex mechanical and chemical factors that go into making a firework. And we're going to go over how simple fireworks were created from gunpowder to complex, beautiful works of art.
We'll start with a brief overview of the Bohr model. Bohr came to the conclusion that the atom gives off radiation. The wavelength of that radiation is going to vary. And as it varies, we're going to get this nice smooth spectrum and spectrum of electromagnetic radiation given off by the high energy of atoms. But when we started to look into space, what we found was that light wasn't smooth. It had these discrete units within it. And so that spectrum had to be described, and the Bohr model helped to do that. Bohr developed a quantum model for the hydrogen atom, meaning that an electron can be in any energy level, like level 1, level 2, level 3. However, it cannot be found in between the levels.
So fireworks are made out of hot embers of metals, and it turns out that many metals on the periodic table have characteristic color that form when they're heated. This happens with extreme temperatures where they are hot enough to excite the electrons. However, every atom is going to be different. There are a number of electrons on the outer shell that is going to be different. There are also the distances from one electron shell to the other will be different as well. This is why we get such a variety of colors. When we excite them, the electrons jump to an excited state where they are further away from the nucleus than they want to be under those. That energy that you've given it and then wants it to release that energy. So relax will come back down to the ground state or close as they can be to the nucleus. As they jump down towards the center, it's going to release its pockets of energy. Quanta of energy, and it's usually expressed light frequencies of light. So if we get low frequencies, we should see colors like red. And if we see high frequencies, we should see colors like purple. The modern recipe for gunpowder is similar to the ancient Chinese recipe. This usually contains potassium nitrate, charcoal, sulfur in a 75-15-10 ratio by weight. The explosion of the gunpowder releases an amount of gaseous products as summarized by the equation below. If loosely compressed, the gunpowder fizzles. However, compressed powder can be made to burn faster, thus the release of gas is much faster.
Compressed gunpowder is located in the charge, which is connected to the fuse. The fuse triggers the gunpowder, which propels the firework into the sky. The color of the fireworks are created by the aerial shell. The aerial shell is located above the charge and contains gunpowders and stars. The secondary fuse is called a time delay fuse, which is connected to the primary fuse that goes to the charge and to the aerial shell. The time delay fuse is made up to run down the peak of the fireworks height. So when the aerial shell explodes in the sky. Oops. In traditional Eastern fireworks, gunpowder has been located in the center of the shell, with stars placed around it. In European fireworks, the most modern fireworks, the stars are placed around the configurations to design with different stars instead of spherical effect achieved by configurations of traditional Eastern fireworks. Many fireworks are not simply explosive stars. Fireworks often have different designs and different compositions and arrangements, having twinkle lights and smokes and sparks like that. The stars in the aerial shell are composed of 4 different elements: a fuel, a colorant, an oxidizing agent, and a binder. A binder keeps a star together and is usually made out of some sort of resin. The oxidizer and the fuel provide energy, in the form of heat, and for the colorant and the regulator for the temperature at which the firework explodes. The colorant, usually a metal salt, changes the color of the firework. A chlorine donor may be present and intensifies the color, as well as can be an oxidizer. The oxidizer and the fuel react in an exo-reduction oxidation reaction, meaning the electrons are transferred between molecules during the reaction. The oxidizer, or the oxidizing agent, oxidizes the fuel, meaning it takes away some electrons. The fuel gives the oxidizer electrons, meaning it acts as a reducing agent.
Without colorants, fireworks would appear orange, yellow, and white due to the incandescence created by the high temperature at which they explode. However, colorants change the color of the fireworks by absorbing the energy of the oxidizer fuel reaction and emitting it as light. As colorants absorb heat from the explosion of the star, electrons in the metal move to a higher energy level known as excitation. The different colors in fireworks are the products of different metal salts. Since electron orbitals are specific for elements and exact wavelengths are preferred for vivid colors, certain metals are used to make certain colors. So we're going to show a video explaining this.
We're also going to watch this other video from a well-known chemist in pyrotechnics. He has a PhD in physical. I forgot what was his PhD, but it was physical chemistry, and he's going to give a brief introduction of like how chemistry works in these fireworks.
I'm John Conkling. I'm an adjunct professor of chemistry at Washington College in Chestertown, Maryland. I wrote a textbook, The Chemistry of Pyrotechnics, Basic Principles and Theory. Everything you see at a fireworks display is chemistry in action. The colors are all produced by very specific chemical mixtures that produce beautiful color flames. The sparks are small pieces of fuel that continue to burn in air. Without chemistry, you couldn't have the burning mixtures. Without the burning mixtures, you wouldn't have fireworks. Every pyrotechnic composition has at least one chemical that's oxygen-rich, an oxidizer. Potassium nitrate, used to make black powder. Potassium perchlorate, used in a lot of color compositions. Strontium nitrate is an oxygen-rich chemical, but the strontium being in there also produces a red flame color. Then you need a fuel that's going to combine with the oxidizer to produce heat. The fuels are things like sulfur, charcoal, aluminum powder, magnesium powder. You vary your fuel to get a specific heat output, specific burning rate, to try to get the exact behavior you're looking for in your chemical reaction. Most people, when they think of fireworks, think of the sky exploding. This is an aerial shell. This is what people go to watch a fireworks display and see. It's a cardboard casing. The bottom has a little pocket of black powder, granular black powder propellant. There's a very important time fuse that goes from the propellant into the center of the casing. That determines when this shell is going to burst up in the air. The inside of the sphere itself has a black powder bursting charge, and then a number of little green pea to marble-sized pellets of chemical mixture that will produce different colors, different visual effects when the shell bursts open. So this device is placed in a mortar tube, a fuse, or if it's going to be electrically fired, a wire, and extends out of the mortar tube. At the exact time you want to fire it, the signal's given, the button's pushed, the propellant ignites and throws this device up into the air. At the same time, this little delay fuse, which is running from the propellant up into the center of the shell, is burning. And then 3, 4, 5 seconds later, depending on how high you want it to go, burns into the center of the shell, lights that gunpowder bursting charge, and boom, blows the shell open up in the sky. And you see the beautiful colors, the sparks, all the effects, the patterns that have been engineered into the device. We produce colors by using the fact that different chemical elements heated to high temperature get rid of this energy by emitting very specific wavelengths of light. This is the stock room where we keep a broad assortment of chemicals. Copper oxide, a chemical that will produce a very, very nice blue flame color for us. And for a red, you'd look for a strontium compound. Here's strontium chloride. Sodium, of course, will produce the yellow-orange sodium silicate. Calcium makes a nice yellow-orange. Here's the calcium nitrate or the calcium carbonate. If we want a green color, we need some kind of a barium compound. This is barium acetate. You look for chemicals that don't strongly pick up water, that are not hygroscopic. Safety first. Anytime we have students in the lab or I'm doing demos, everybody has to have their safety glasses on. Now, the glasses I'm wearing are polycarbonate lenses, which are shatter resistant. But when I'm around energetic chemicals, I always wear the extra protection of goggles or side shields. To produce color, you start with a burning mixture. You need an oxidizer and a fuel, and then you add the other ingredients, the color-producing ingredients to it. This is a mixture of potassium perchlorate and red gum. Now, instead of red, now we want to produce green, so we've added some barium carbonate. Blue is the hardest color to produce pyrotechnically. You need perfect chemistry. This is copper oxide. This is a red flame composition from strontium nitrate. It's a very bright flame because it has magnesium, a magnesium aluminum alloy in the composition to raise the flame temperature. I've taken my base mixture and added moderately coarse magnesium. This should produce a nice white spark effect. When I'm not sure exactly what's going to happen when I test something, I'll use a little piece of fuse. And I light the fuse. It gives me a time to step back just a short distance. There goes the fuse. Fireworks make people happy. There's something about watching that night sky explode in color and sparks and noise. I think gets really deep in the human soul, and seeing the night sky explode in fire still brings chills to a lot of people.
So these are the common chemicals that are used in multiple manufacturer companies. Since fireworks is like a billion-dollar business. They're going to need a lot of oxidizers and fuels. And like you said, it's kind of hard to achieve a blue flame. So I think it's all interesting. And a fun fact is that lead and cadmium and mercury have been altered, like stopped, because it's very hazardous for fireworks and for the environment in general. So they stopped using those, and some companies just don't want them anymore. And thank you for listening, and thank you for your time.